Okay, good morning, ladies and gents, and thanks for attending another Thursday morning Zoom presentation with the Overberg Group. And I'd really like to welcome Gerhard Meintjes to the podium today. So Gerhard is a geochemist. He graduated with the BSc Honours in 1984 at University of the Orange Free State, and then also completed an MSc and a PhD there, his PhD in 1998. Like many of us, he then joined the big companies at that time. He started off with Agglomerates, where he spent a year or so, and then moved back to Stellenbosch to actually lecture in geology. From there, in 1995 to 98, he was a gold exploration geologist at Goldfields, and then left the big company fold and opened up his own consulting business, which he ran very successfully for many years. His focus in industry was on exploration ventures and a range of minerals, including chrome, platinum, gold, nickel, base metals, coal, and more. But his sort of long-term passion and interest has always been the Ventersdorp volcanics, Ventersdorp lavas. And he's going to talk to us today about the Ventersdorp. In his sort of semi-retirement, he's been very active, going back through miles and miles of kilometers of core, and getting out in the field and re-looking at both the Ventersdorp and the main basin and the sub-basin. So thanks, Gerhard. We look forward to your presentation.
Thank you, John, and good morning to everyone. Yes, the Ventersdorp represents no less than 3 large igneous provinces, so we'll have a look at that. I aim to give some detail on each of those and also indicate some of the shortcomings we still have on the Ventersdorp Supergroup, not just in detailed data, but also general knowledge on it. The data you'll see in this presentation are mostly public data, but also some company exploration data and also data that I haven't published yet. And it's based on about 1,400 boreholes that I have cross-referenced and checked. Some of them I've logged, and a substantial number of thin sections and also geochemical analysis. Also would like to give acknowledgement to Prof. Nick Grobler that introduced me to the Ventersdorp Supergroup, and also Willem van der Westhuizen, that was my supervisor. And we're collaborating with Dave Cornell on dating and various issues. Through the years, many colleagues had great discussions with them on the Ventersdorp Supergroup, especially in the exploration industry. The Ventersdorp Supergroup overlies the Witwatersrand Supergroup. So where you draw for Witwatersrand, you typically have to draw through the Ventersdorp Supergroup first. It outcrops very badly, very poorly, and so most of what we know about the Ventersdorp comes from exploration drill holes. It did suffer boreal metamorphism, so everything is green. It's composed of 3 groups: the Klippriviersberg group, which represents the first large igneous province, the Bloodberg group, which is the second, and the Pineal sequence, which is the third. The Klippriviersberg is composed of basic to intermediate lavas, some minor sediments at the base, and it represents a flood basalt event. Basically, composition is really a high basalt to a basaltic andesite. I don't like composite thicknesses for these successions. The real intersections, most of them are less than 1,000 meters. Most of the thicker successions are about 1,500 or less, but there are some that approach 3,000 meters without any duplication. The Bloodberg group is more evolved volcanics and sediments that's interbedded throughout the succession, representing rifting that followed the flood basalt events. And the deepest intersections or the thickest successions are over 4,000 meters, with some of those boreholes not having penetrated the base of the Bloodberg. So it's substantial in certain areas. The Pineal sequence is composed of a regional sedimentary formation, which seems to be disconnected to the overlying intermediate lavas. So regional penoplanation took place after the Bloodberg Group and then was followed by what I can call a flood andesite event. Mostly less than 1,000 meters thick. Some areas, the total succession do approach 1.5, maybe closer to 2,000, but rarely so. So let's look at some of the limitations that I see in the data we have. Most of the publications and data do not represent a complete succession. There's major parts of succession missing, which leads to frequent correlation errors. And there's, in fact, not any of the data sets or theses or publications, including my own, even recent ones, that's not without its problems. So if one uses those data, you better thoroughly interrogate it and make sure you do cross-check it against data that you and borers that you have knowledge of. The tendency in publications is not always to present the data on which it's based or the raw data. And there's also poor sample traceability, which is very frustrating. You can't really build on that data and understand what they did on samples from where. And in industry, it's even worse. I mean, the Ventersdorp Supergroup was always joked as overburdened to the wits gold. So there was never really time and budget to do more comprehensive work on that. So in this presentation, you will frequently reinterpret it and did revisions of the published data according to the factual data I have on borers. Give you an idea what the problems are. This is a photo of an absolutely perfect welded, highly welded igneous. It's McQuasy outcrop. And I've got the sample here in my hand. I don't know if you can see it, but one of my external referees on my PhD thesis failed the thesis because this was considered to be a myelinite. It took me 7 years to correct that problem, but nevertheless, the problem is, in general, geologists here, also academics, really have the chance to see these rocks and to realize how pristine they are and what they are all about. And that we need to correct. You need to understand the history of stratigraphy of the Ventersdorp Supergroup to really understand it better. First rocks that were described in the interior of South Africa, geologically described, was in the mid-1800s. And in the early 1900s, there were a lot of work done with mapping and further descriptions. The various outcrops were described as different formations and groups, and it already started indicating that they're all the same thing. And it took several more years before Henk Winter, in his PhD, based on borers in the Botawil area, made sense of it all, and his stratigraphy of the Ventersdorp Supergroup still stands. It was only published in 1976. Since then, only the Ventersdorp Post Formation became part of the Ventersdorp Supergroup, and the Goed Genoeg Formation, still unrecognized by SACS, has become widely used. Already these were indicated by Henk Winter to be part of or should be subdivisions in the Ventersdorp Supergroup. And of course, since then, geochemical information and geochemical stratigraphy also became part of the picture. And I just want to point out some of the older groups of formations, like sootleaf and sodium, etc., are really defunct now and are known to be part of the normal Ventersdorp Supergroup stratigraphy. So Henk Winter's work were largely based on the Botawil Gap, where there were sufficient borers to make sense of, especially the Bloodberg Group. Subsequent to that, in the late 80s, early 90s, Agglomerates added about 140 more deep borers in that area. So there's much more information of the detail, showing that Henk Winter's stratigraphy is correct, but there's much more complexities to it. At the peak of that project, I think there were something like 40-odd deep drill rigs going at the same time. It was like a oil field, very, very interesting and exciting to have worked on that project for a while. My interest through the years have really been about the Ventersdorp successions outside the Central Rand Group Basin in yellow there. There's some outliers or sub-basins of the Central Rand Group, but there were boreholes drilled during the 80s and the 90s in the areas out here, and very few geologists have ever seen those boreholes and have worked on them, and that changes the picture. So let's start. The West Driefontein subgroup at the base of the Klippervuursberg group is composed of the Ventersdorp Formation, which contains the well-known Ventersdorp contact reef, some minor sediments at the base there, and some of the overlying Western Area Formation lavas are interbedded with these sediments. In this column on the right here, I have the descriptions of winter of 1976, of what the succession looks like. He based these distinction of these formations on macro textures. We will look at that as we carry on. Western Area Formation is described as talco tuffs, but of course they're really lavas, and really in some of the mines they were exposed in the mine workings. Ventersdorp contact reef at the base here, that's what you mine, so you really go into the hangwall, into the lavas. And here you can see fantastic well preserved pillow structures of the first lavas of the Western area that form pillows in these waterlogged channels of the Ventersdorp contact reef. The Alberton Formation have some porphyritic zones in it. Generally, all of the lavas in the Ventersdorp Supergroup look something like this: green, altered to some extent, fractured, filled with chloride, etc., and so on. Most of the photos you'll see in this presentations will be of half core, split core, and it's lying on its, or is turned on its side, so up in the borehole to the left and down on the right. And you will see a scale at the bottom. This guy is centimeter scale. So the Alberton Formation is distinctive. It's got this distinctive porphyritic zone in it, euhedral feldspars, and in some areas they can get very large. And the euhedral, they didn't form in the magma chamber; they formed in the lava flow. They're not broken; they're not resolved in general. This specific sample and the next ones are not from the Alberton, Mondior, Central Rand area in Johannesburg, but about 200 kilometers away from there. We generally see these phenocrysts as indication of closer to the source of the erupt or of the lavas, because the larger they are, the probably longer it took, hotter the lava was, and the longer it took for the crystals to grow. By the time you get to the Free State Goldfield, you rarely see very tiny phenocrysts, very hard to spot. This one has been resolved a bit, but typically they show these swallowtail textures, which are indication, if I'm understanding correctly, of rapid growth. The lava flow tops typically are break-shaded, so they really are lava flows. In this case, also showing some alteration, which one see often in the Ventersdorp, especially in the Klippervuursberg, some epitheralization and color variances because of the alteration. The Orkney Formation were described as ash flow tuffs. Of course, they are lavas. In the flow tops of the lavas, you see amygdales, typically filled by chloride with a bit of a reaction rim. And as you go higher up in the Klippervuursberg group succession, the amygdales get progressively more filled with quartz and lower temperature minerals. In the Orkney Formation, they got these strange purplish maroon colors, and one can see it's really part of the alteration taking place, and it's like devitrification spherolites forming with fine hematites spreading in a sphere from a center. The net information described as agglomerates. They really are lava flows. And in this case, very rarely you sometimes see at flow tops some fine tooth that infold the breccia. Remember, like I said, its core up is to the left, and it's half split core in most cases. Some description of what agglomerates really are. It's rife in South Africa, used in academic and in industry. They're not really agglomerates, most of them. I don't think one will easily realize if it is actually an agglomerate in drill core. They are lava flows. Agglomerates should be very close to a spatter cone, and all these can't be close to a spatter cone in any case. The rain formation is quite spectacular in places. It's precritic basalts that were glassy, and during the devitrification of these lavas, these spherolites form. These are quite large, and usually much smaller than that, and quite spectacular. Really large ones here. And the Igneous formation at the top, quite distinctive. By then you have quartz fillings in the amygdales. They're often of green color. Sometimes also very large ones, almost like bugs, big openings that were filled by quartz. You also see some epidendrization in this photo. So if we need to update the macro descriptions of these formations, it should be something like this. Winter in the previous slides indicated maximum thicknesses that he saw on borals, which can vary quite a lot. But I tried to indicate here that the Igneous formation can be quite thick and dominant in the succession where it is preserved or deposited, while the lower formations are not that substantial. Orkney formation can be quite thick. So we say inclusions are rare, really rare. They go mainly in the basal formations, or that's what I saw. And then any tuffs or probably reworked volcanic materials, some volcanic sandstones, or you only start seeing higher up in the succession. There are no true sediments in the succession that I saw. So it's regionally also exceedingly consistent, all these formations. And I wonder if it wasn't formed at elevated altitude. The inclusions that one see, sorry, I see there's some messages coming up. I hope everything is still okay. These are some rare inclusions in the lower formation. There's, it's probably recrystallized quartzites. I don't know, maybe it's basement. And one also sees some deformed vein quartz accidental inclusions. Also probably basement granites, probably also recrystallized. And then towards the top, like I indicated, some airfall tuffs infiltrating the flow top breccia. At the top is a long piece of core, and I just blew up or took a picture of more detail here and that you see at the bottom. And some more detail of that, very fine detail. You can maybe possibly even see accretional lapilli sitting in here. And in this case, a proper few layers of accretional lapilli. Just to orientate ourselves, we will concentrate on this carb wall craton area with the various blocks in some of the maps I'll show. So if I look at the distribution of the Klippriviersberg group, it is largely restricted to the Witwatersrand block or terrain. It's not occurring south of Bloemfontein, as far as I know, and also not in the Kimberley area. We'll just have a look at the Swaziland area just now. These borers that I indicate here is about 500 of them, but by no means all of the borers that exist, or all the data that one can make use of, but that's what I have in my database. My database largely concentrate on the western part of the Central Rand Basin, like one can see from the borers here, because of my interest in the Bloodberg Group, and also further westwards. If one look at the data that was published by Gumsley et al. On the Mfolozi dike swarm, which is over here, and they sample there, sorry, that's Amsterdam sample here, just to indicate on the larger map where the area is. And if one look at the diagram that was used and devised by Bowen in a thesis in 1984 and published in various publications later, it works quite well for the Ventersdorp Supergroup. And it's this specific sample ENED08. Although it plots here in Ellenreach, the Klippervuursberg data does stray a little bit into Ellenreach, and it's most certainly a Klippervuursberg sample of that, or that dike is of Klippervuursberg material. So that increases the depository substantially. If I can go back to the previous slide, also add a look at outcrops here and work that Goldfields did in that area. There's most certainly a succession of Klippervuursberg group in that area as well. A brief look at the geochemistry. In green is the outcrops of Klippervuursberg group, and here are the localities, borers and outcrops on which this data, where the samples were taken. We will see they are really high basalts, low andesites, and the subalkaline, thalliatic, and certainly plate margin or volcanic arc, something on the edge of a craton. That's what the origin is. Plotting all that data on the Bowen diagram, if I can call it that, like I said, it does stray a little bit into Ellenreach. All this data was verified. It's actual, I'm happy that it's Klippervuursberg and not some miscorrelations. Just want to indicate that the Bowen data didn't include the upper part of the McQuasy, and I realized that, but they didn't have material which plot all the way over here. So one have to adapt the diagram a little bit if you want to use that to discriminate between the various formations. Linton and others did work on the geochemical stratigraphy of the Klippervuursberg group. And yes, then the picture looks different. So the macro textures, the macro recognition of the formations on the left here does not really gel with the geochemistry. It works quite well on the macro characteristics when you do exploration, you drill holes and you want to, because you constantly want to know where you are on the succession. But when it comes to geochemistry, it looks quite different. This is the type section of the boral LL1 that Henk Winter used for his succession. So just be aware that the geochemistry and the macro textures don't gel, and there's much more work needed on this. So I think doming started before, after the Witwatersrand, before the first volcanics started, volcanism started in the Ventersdorp Supergroup. It's mostly Pauaoi, AA, and block lava flows, initially of low viscosity and progressively high viscosity until you got to the Lorraine, Genetic Lorraine formations. It seems that there's a new cycle of magmatism starting at that point. Also a slight break or a slight time lag, less activity happening at that stage. It's of course subaerial eruptions, and it certainly must have erupted from fissures, but where are they? I don't think we really know, and we need to do more work on that. But there's also some water deposited lavas, yellow clastites, and substantial areas of that, and the full succession of Klippriviersberg deposited in that. One wonder if there wasn't glaciation during that time, and I hope to see Spike McCarthy's forthcoming paper one day that is working on, that will be hopefully published soon on that. This is what the haloclastites look like in drill core, in thin section. It's perfect examples of altered glassy lavas that were deposited in, must have been quite thick successions of, or thick, deep water, otherwise subglacial eruptions could also have been. So what do we need to look at? I don't think we really understand the structural geology of the Ventersdorp Supergroup that well. It's been poorly researched. Everything that happened afterwards, the rifting during Bloodberg, has affected the Klippriviersberg, and a lot of that structures are not known in the Klippriviersberg because we haven't studied them. We also don't understand the transport directions of the Ventersdorp contact reef that well. Certain areas have been studied well, but some of the work I did in industry is exact opposite to what the general, exact opposite transport direction from what is generally published and believed it to be. We need to do more on the geochemical stratigraphy. The work that was done in the past were specific areas, but we got much more that we can work on now. And the minimum volume that was done by Linton and his co-workers is quite a substantial volume of volcanism. I did a quick calculation, a very rough estimate, and it's in that ballpark. But if the Natal occurrences indicate a continuous depository, maybe largely eroded away between that area and the central range, I mean, then the depository and the volumes, of course, increase substantially. These kind of sections through the Ventersdorp has been inherited from early days. And so I don't blame Professor Frimmel, but it's painful to see these and all these faults stopping there. If you're familiar with borers that were drilled through these successions in exactly this area of these sections, one will know that there's substantial duplication and thickening of the succession, and maybe some of those faults is actually going through and were reactivated post Witwatersrand times and influenced the Ventersdorp Supergroup. Let's move on to the Bloodberg Group. 4 formations. Kameeldorens is a sedimentary formation at the base, but there's some minor volcanics in it as well. In some areas it doesn't occur. Any of these formations, same story, but it can be as thick as 1,000 meters or more next to some of these fault scarps. And it's followed by the Goedgenoeg Formation, which is andesitic to daysitic volcanic formation, largely pyroclastic flows, minor sediments, especially towards the top. And then the McQuasy Formation, which is daysitic to rhyolitic quartz porphyries compared to feldspar here at Goedgenoeg. And mainly Agglomerates, some minor andesitic lavas, and minor sediments interbedded throughout. Some successions at least 2,000 meters, usually much less than that. Overlying Redhot Formation, final formation in the Bloodberg Group, andesitic lavas and some minor daysitic feldspar porphyries. And in areas there could be quite substantial sediments, in other areas rare. My PhD study came about because of this borer, these 4 rows here. It was started in outcrop of McQuasy, and it was stopped in Goedgenoeg after almost 4,000. We will look at it now. Just those that's not familiar, these core boxes, it's got 12 rows typically, 1.5 meters of core lying from top to bottom in each row. This is what that borer looked like. It started in outcrop. After 2,000, about 2,500 meters, went into Goed Genoeg Formation. At that stage, still poorly recognized as such, and it was stopped just before 4,000 meters, still in Goed Genoeg. There's no duplication in this borer, and it's also burial volcanic deposits, mainly Agglomerates. Could be some shallow cryptodome intrusions towards the top, difficult to recognize in drill core, but it's most certainly a caldera setting, and there's many more like this. How did it come about that these kind of borers were drilled without realizing the Bloodberg is going to be that thick? In the 1980s, the geophysics could not, and especially gravity, it's difficult to distinguish between Witwatersrand quartzites and felsic volcanics. So typically the estimated geology of a borer would look like this. This is a borer in the Vryburg area, and Ventersdorp Supergroup expected at about 2,500 meters. And in the end, they drilled into andesitic lavas, still unrecognized, doesn't really look like Dominion, but was a bit of a puzzle at that stage. And that's how Anglo then sponsored a project to really look at the succession and try and make sense of it. The detail of these formations, the Kameeldorings is a boulder diamictite in some areas, and it can go all the way to very fine-grained shaly sediments and some minor volcanic rocks, especially towards the top. You can have Goed Genoeg lavas interbedded with the sediments. In some of the Bloodberg grabens, there's no volcanics that were deposited, and in that case, it's just sediments. And in industry especially, it was called the clip-on formation, and difficult then to understand if it is early, all of it, or does it represent the whole time span of the Bloodberg? Most probably the latter. Kameeldorings can be quite spectacular. This is underground, an old mine workings, pretty hairy area, quite big boulders. They're all rounded. Strangely enough, wonder what that means. And they can go to really a gritty mix of mainly volcanic fragments to very fine-grained sediments. In this case, some calcareous layers been replaced by silica. Even low down in the Kameeldorings formation, you do see some tufaceous material, and in this case, even very nice accretional lapilli. So it is probably Bloodberg volcanism that started early on in the succession, and therefore I don't see in the hard rock geology a big time span between Klippervuursberg and Goed Genoeg volcanics. Although our dating at this at present indicate a substantial gap of 60 million years. The Goed Genoeg Formation, like I said, andesitic lavas and daysites, minor sediments. Just as an explanation of the Goed Genoeg and McQuasy formations, Goed Genoeg is dominated by these andesitic lavas, especially outside the Central Rand Basin. And then towards the top, more common daysitic pyroclastic flows, with some sediments especially appearing close to the contact with the McQuasy Formation. So these same andesites, same composition occur throughout the succession, interbedded with whatever else there is. In the case of the McQuasy Formation, we have a daycite at the base, quartz porphyry. It looks very similar. You won't recognize it easily in core. It's just the geochemistry that indicates that. And then followed by rhyolites at the top. Especially west of the Central Rand Group basin, you see much thicker successions of rhyolites developed. What does it look like? The Goed Genoeg andesitic lavas. The core continues to the right here and to the left, so it's just a a close-up of a section, very large amygdales at the flow top here. The contact with the next flow is out of picture on the right, but there you see some pipe amygdales at the base of the next flow. Thin flows, it's about 1.5 to 3 meters thick. There's the top of the flow already. And at the top, you see the start of the next flow, pipe amygdales again. The Daysites, pyroclastic ash flows, Agglomerates probably, all of that. It can be quite spectacular. Outcrop in Freiburg area with some lipoli. And some more of that. In the Agglomerates, at the lower parts of the Agglomerates, which can be quite thick and very difficult to recognize exactly what they're all about in the Goed Genoeg because of the dark alteration, they can be highly porphyritic and less so towards the top. Same in the McQuasy Formation. Towards the top of these Agglomerates, you often see amygdales, difficult to spot sometimes. In this case, calcite, largely filled by calcite, which weathers a little bit darker, and you can recognize them. And then towards the top, quite often tufaceous sandstone, and infilling this the flow-top breccias and some highly calcareous deposits, now largely silicified. McQuasy Formation. Like I said, mainly rhyolites. The Daysites are common in the Waterville Gap area, but outside of that, less so. You typically see Agglomerates with this kind of succession in it. You see a basal glassy, and now a devitrified, originally a glassy contact zone, where chilled, very phenocryst rich base of the basal part of the deposit, and there more massive middle part with eutexotic textures, and then towards the top, amygdaloidal area, which can be quite substantially thick, where the amygdales are recognizable, and a breccia at the top, followed by some reworked volcanics or airfall tooth, and then the next succession. These are often in the region of 700 meters thick, and lowest or the thinnest is about 80 meters or so. So it's really substantial. There you see the basal contacts with this originally glassy zone at the contact. Some tufts here at the top of the previous flow, which ended here. And this is the contact zone, like I said, and then quite altered lower zone of that ash flow. Underground, very old photos, not that good quality, but there you can also see the sort of reddish colored glassy zone of this flow overlying a more lapilli rich ash flow, probably not as nearly as welded as this flow. One often see a lot of mafic inclusions in these Daysites, especially lower part of the McQuasy, and these look like cognate inclusions, not accidental inclusions. So maybe there was some magma mixing involved, although we don't see too much evidence in the geochemistry of that at this stage. The lower part, extremely phenocryst rich in some cases, and often these have been described as granites, and also an outcrop, some outcrops, and still some areas on the geological maps are indicated as granites, while they're actually McQuasy Formation. Not going to go too much into thin section of it, but there you can see the typical extrusive volcanic textures of your phenocryst being resorbed, one of those mafic inclusions without reaction rims, and the quartz phenocrysts are quite resorbed and often extremely so. Look at the width of these fields. It was taken with a special microscope, and had large thin sections made, which really revealed the textures better than normal thin sections. The middle parts, you see these nice geodesic textures, quite altered in this case, the core. Outcrop sample or underground sample, you can see that's a bit higher magnification. And then even in thin section, you see the geodesic textures quite clearly. And at the top of it flows some tooth infalls of the breccia, and in thin section you can still recognize glass shard textures, but they've been calcified and quite altered, more permeable, I guess. The andesitic lavas in the McQuasy often have very large amygdales towards the top, but they're clearly recognizable as lava flows. And there's some Daysites, Agglomerates overlying it. Sediments often quite dolomitic sediments, but quite silicified now. When you cut, that's pretty hard stuff. Don't have that much left of the calcareous sediments. In outcrop, the same story, quite clearly visible here at Richie. Geodesic texture of a Igneous. And yes, there's some of these that are spectacularly rich in phenocryst and very large phenocryst. But if you look at the matrix and thin section and so on, definitely, in my opinion, still extrusive. Underground, some interesting features. It looks like this Igneous has dragged the one below it, which is very dark, which we could see deeper down in the mine, less welded, dragged it along. So it was probably still unconsolidated. Rarely, and in some areas restricted to specific areas, one also see what I interpret as rheomorphic Igneous, and can be quite interesting. Then also probably alloclastites, and they're quite common in some areas in the Bloodberg group, especially in the McQuasy Formation. And if one compare that to the photos of the fantastic book of McPherson et al., one see that's probably what they are. We always call them hydrothermal breccia, not really knowing what they are. And there's some in drill core. And I had the opportunity to include a fly as scale the top for us. Redhot Formation is actually quite widespread, mostly andesitic lavas, and in some areas it's only it's represented by very thick successions of sediments. Like in this borehole, this is all Goed Genoeg Formation, and this is all Redhot Formation, but just shaly sediments. There's more core here than the actual Redhot because there's about a 600-meter thick bushveld intrusive in this succession, overlain by Agglomerates and then Transvaal Supergroup. In Redhot, there's very nice outcrops with creasing lapilli, very spectacular and quite widespread in some areas. Distribution from boreholes, mostly Central Rand and West, of course, also some outcrops here and some minor occurrences here, probably mostly eroded away, I don't know, but it's definitely also occurring in the Kimberley block and further. We had a look at the Amsterdam area. We'll look at the Gumsley data just now, but there's definitely McQuasy Formation there from Goldfield's work and what we've seen in the field. And the Dennilton Dome, the rocks certainly don't look like granites or gneisses to me. Been there with Frikkejaertser and with Goldfields. And also the geochemistry is exactly the same as McQuasy. Look at Gumsley's published data. It is this sample PRGE, And it does look like it is part of Goed Genoeg, or it could be McQuasy Formation, andesite lava, or Redhot, because they all have same composition. But it certainly does look like it is Bloodberg. These are basaltic andesites. Andesites mostly Daysites and rhyolites, and one can look at various other discrimination diagrams based on immobile elements. One see the same. As I mentioned earlier, Bowen diagram works quite well. It does stray a little bit into Dominion, but if you look at other geochemistry, Dominion mafic lavas has different composition from the Bloodberg. And the Goed Genoeg, the McQuasy rhyolites does carry on quite a long distance here, but does not really overlap with the medium. So one need to adjust the diagram a little bit, and it works well. One can see distinct geochem groups in the Bloodberg, and one can correlate them regionally. They occur throughout the region, not always all of them at a specific area, but one can trace them. It's still not officially recognized by SACS. We hope to get a publication out soon that rectifies that, because it's certainly a regional formation. And as mentioned, not all the grabens have volcanic deposits in them. Redhot is not localized, as I always thought. It occurs more widespread. Something else one see from the seismic work that has been published and other work that's not been published, a lot of these Bloodberg grabens, they're not really orientated north-south or northeast-southwest, but they're orientated east-west. And there's certainly caldera complexes west of the central Rand basin, and they often are, and I think in this case also nested complexes. Very difficult to make detailed sense out of them because of limited borals that are available, but one can trace them. And the Goed Genoeg volumes that I roughly calculate approaching 100,000 cubic kilometers, McQuasy much more, and Redhot much more substantial than what I thought many years ago. So in total, this is almost 500,000 cubic kilometers. And if we extend it further east, then it changes. The last part of the Ventersdorp pineal sequence, waterwall formation, are sediments, usually about 200 to 300 meters thick, sometimes a bit thicker. A lot of the data one see in borals is unreliable. I think they often included Bloodberg sediments in some of the logs, and then they very thick, but from what I've seen, it's incorrect. Agglomerates formation, usually only about 500 or 600 meters or less in thickness. The thickest I know of is about 1,200 meters thick. Waterwall, very nice quartzites. At the base, some conglomerates, usually just Bloodberg volcanics, rarely something deeper down like Wits, but usually just up a Ventersdorp material that's been reworked. And towards the middle and lower middle, one often sees shell layers that's been ripped up. And even there, and even lower down, one see what looks like accretion lapilli. I haven't seen these in thin section yet. My thin section's a bit too thick. I'm not happy with them. We'll have them redone. But if this is true, then it changes the whole waterwall formation story, because there was volcanism somewhere else. Agglomerates formation, very straightforward, andesitic lavas, typical lava flows. I didn't include diagrams with plots of lava flow thicknesses here, but they're anywhere from 1.5 to 10, 20 meters, maybe where the conduits. And in the Agglomerates, you often see very large, like agates fillings of the very large amygdales. And that's one way you really recognize the Agglomerates very easily from Klippriviersberg. Also because it's been much less affected by any tectonic movements. It has several phenocryst or porphyritic zones, often very fine, small phenocryst. Haven't made sense out of it yet. It doesn't look like it's a good marker horizons because there's several zones and it seems to come and go. As mentioned, sometimes very fine. I know this looks like a dolerite, but it isn't actually. It's just quartz, very dark, very altered. I think the succession was maybe buried afterwards. In this region, the whole Allen Ridge seems to be very dark. In outcrop, our lava flows, phlotobrexia, quite nice. It's in this case, I think the top of the sample is actually to the left. And in drill core, this case highly altered with epidite epidite very prevailing in this sample. Distribution mostly westwards. The blue is the outcrops. The seismics indicate it carries on all the way to Craton Edge and get thicker towards that area. I'm not sure if that's true, but that's what the seismics indicate at this stage. Again, andesites, litholetic, seems to be plate margin setting. On the Bowen diagram, fairly tight plots of quite a number of samples, and there's a peculiar group of samples in a very small area that seems to have a different composition, and it's at the base of the Allen Ridge. There's no publication on that yet, but hopefully that will be included in a forthcoming publication. So the Allen Ridge are, I think, mostly just Bowie and our lavas. Very rare tuffs and sediments. I haven't seen much. I haven't seen anything that looks like haloclastites in it. The andesite, again, there's distinctive geochem groups that one can recognize, and you can correlate regionally. Thickness usually much less than that, but there's very little tectonic deformation in that, and it's probably much more substantial than what we consider at present. I just wonder if the Allen Ridge didn't have a felsic event as well, which is quite normal, and we must correlate something, or we just don't recognize it for what it is. So, in conclusion, the Ventersdorp Supergroup is about 2.75, 2.2 million years old, but it's pristine. It's still flat lying. It's been little affected by any tectonic deformation. Yes, it did undergo burial metamorphism, but not to a high grade. And it perfectly preserves 3 major Archean large igneous provinces, but we haven't studied it very well yet. And we must do something about that. We've got all this drill core, and that drill core is not of much commercial value at all, and we need to preserve that. My rough estimates of some of the core yards I know has got these kind of meters in them. To replace that, I mean, just the drilling cost is substantial. Nobody will drill these holes ever again, I think. And it would be a travesty if we don't do something about that. This is what it must look like, and not like that. And we must work on this core. It's most of this core still pristine. It's absolutely fantastic to walk into a library like that. Thank you very much.
Okay, thanks, Gerhard. Do you want to unshare, and then we can get questions and answers going? I'm sure there's plenty of them.
Yeah. How do I get out of this thing now?
Go back to your share and click on it.
Yeah, it doesn't want to come up, but I think we can start, John, if somebody got a question. Yeah, there we go.
You got
it. We got it. Thank you.
Maar ek het sommer ingespring. I was just on another call.
Ja, dankie. Thanks, Eddie.
We've got some questions in the text side that you can kick off with. Can jy die text sien?
There's a question about how far does the Jeanette extend eastwards, Gerhard? Is it intersected in the Evander region? Must be an old gold geologist.
John, probably, I don't know that much. I've never worked specifically on the Klipperviersberg, and during the years that I now restarted the research, I haven't really focused on getting my database up to date on all the different formations. So it's possible. I don't know. I'm not really familiar with that. I can't answer that.
Okay. Then Chris Hatton has a comment. He says, excellent image of the Igneous. Nils Lennart, 2017, also sees Igneous in the Rooiberg.
Yes, I don't know Rooiberg that well, but what Jochen Schweitzer has showed us, certainly highly well at Igneous, most certainly.
And then Gerhard, just on the ages, I mean, is there any more precise data? I mean, I know the rocks are somewhat altered and you don't have many zircons and so on around, but you're talking about, LI flips and saying there's effectively three major LIPs, and my information, or what I read, and Andy and Duncan and others might want to comment. I mean, most of these large igneous provinces tend to be very rapidly extruded and very time constrained. And you threw out a number there from sort of 2.2 to 2.7, if I heard you correctly. And I mean, are those different groups? I mean, they look to be, well separated stratigraphically, so to speak, but are you seeing any new age data to constrain them better?
John, we published a very good dates that we're very happy with, Dave Cornell and us, on McQuasy. And we also tried Goed Genoeg, but there's very little zircon we could work, or you could work on. But the McQuasy is 2.72 and very good, well constrained. We're very happy with it. The Klipperviersberg age that's based on dikes that Gumsley and them did, I think is about 2.8. And that gap, I don't like that gap very much because I don't see that big time span in the rocks. Also, talking about the three large igneous provinces, I considered the basaltic event and then the felsic event that typically follows it, not always, but typically is one event, but that's considered to be two separate events now, the mafic event and the more evolved felsic event. So for me, Bloodberg and Klipperviersberg hangs together. If you look at the research that's been done, and there's a lot of very detailed work done in America on that 2,500 meter volcanic belt from Mexico all the way to Alaska. These things happen in relative short time span from the mafic to the felsic event. You can't extrude rhyolites that's sticky like treacle without superheating them or causing something to make them come out. They don't come out as lava flows. They can only come out as pyroclastic flows. You have to do something to convince them to come out. And if you have 60 million years, you have to keep your mafic magma system going, your heat going. So that's how I understand it. I could be wrong. I don't. Somewhere something has to shift as far as I'm concerned. Problem is we can't directly date Klipperviersberg or any of the felsic andesitic lavas in the Goed Genoeg. It seems we're still struggling with that. The other problem is that far north, there's dates on Kanye, etc., and so on. That's a whole can of worms. I don't think we should discuss that today, but those ages are about 2.8. Yet there's boreholes that drilled through McQuasy, Klipperviersberg, and the whole normal succession geochemically, but it's indicated as Kanye even on the maps, and that's not Kanye. But somewhere there might be something changing, and I think our field work is not that correct at present. And I think our dating needs to get much more attention. But we must make sure what we date. So some of the work was done on stuff that's not that is not well correlated yet, I think.
Good. Okay. Nigel, perhaps you want to chip in there on your dating or the dates you just referred to, Nigel Hicks.
While we're waiting for that, Lou. Okay. Sorry.
Yeah, thanks, Gerhard. That's a great talk. Yeah, just you're referring to Ashley Gumsley's work that he's done out in Ulundi area in northern KZN. We've been doing a lot of work out there as part of the council at the moment, and I've done a lot of work there when I was doing my MSc. But yeah, I mean, there's it's quite interesting what he's been coming up with, like ages ranging. Sorry, yeah, I put that 7.28. Should be 2.78. But yeah, there's a range of ages that extends across the entire suite of the Ventersdorp, even to quite a bit younger. It's sort of 2.66. But there's a number of different variations in those dikes as well, from very massive dikes through to highly porphyritic ones, where you've got these very large feldspar sort of phenocrysts and porphyries and that sort of thing. And they look very similar to the Alberton. I mean, they're not as sort of sharp in the porphyries, they're slightly more rounded. But I mean, just having been in the field and seen that sort of stuff, and we're working on some of the Ventersdorp volcanics at the moment at the council in the eastern Evander field. So having seen those and now hyperspectral imagery of the cores, looks very, very similar. So I would agree with you that there's definitely an extension across, but where it links and which unit it links with is obviously up for question.
Yeah. No, thank you, Nigel. Those phenocrysts in the dikes that's around it will certainly be from the magma chamber, while those that you see in the lava flows are in situ formed. And I'm a bit worried about the work on the dikes, because one don't really know what they are. But like I indicated, that specific sample of Gumsley looks like it's goed genoeg, and the age they got for that is also substantially lower and getting closer to that age we have for the McQuasy. So I quite like that, you know. So, and maybe there is a substantial gap between the McQuasy age, the McQuasy, and the Klipprivierberg age. But I'm just saying that from what I see from the hard rocks, I don't see the Kameeldorings or anything else that gives that can indicate such a large time gap. Like you see between the last of the Bloodberg, the Redhot, and then the Agglomerates, you got that Redhot Formation that just simply flattened everything. That is very consistent throughout and same thickness almost, you know, it doesn't vary a lot. That certainly must be a substantial time gap. I just don't know what to make of if that is indeed Krishni Lepilli that I saw on Waterwall. And of course, up at the top of the Waterwall, you also have some indication of volcanics. It's been published before, and I've got samples. I haven't got good thin sections on that. But be that as it may, I can understand a big time gap between Agglomerates and everything below. And same problem, we can't really date that accurately at this stage.
Lou Ashwell wants to know, what do you think of the suggested correlation between Ventersdorp and Fortescue in Australia?
Well, we should get hold of Andy Button and ask him.
Yeah, we looked at that, and originally when what was his name that initiated that work in Australia, I can see him, I can't remember his name now. When he came over, Prof. Nick Krobler hosted him, and we all went to the field to have a look at it. So I've been following that work. I don't see a direct correlation. The geochem don't gel at all. And even that person that I can't remember, he's long passed away, I believe. But even he said it doesn't really see what he saw here, doesn't look like it directly represented here, not that outcrop or macro characteristics should lead one. But I don't see that in the geochem. It could be similar, but I mean, I don't see it directly connected at this stage.
Thank you. And then Mike Dormer wants to know, is there particular significance to the east-west orientation of the Bloodberg grabens?
Most certainly there would be. I'm not clever enough to think up an answer yet on that problem, but just coming back to the same theme that I have brought up a few times, I don't think we understand the structure of the Ventersdorp Supergroup properly, and it directly impacted on the widths below it. And we need to do more work, because we always said the rifting is north-south. Maybe it is, but the overall movement is pulling apart east and west. But it certainly has maybe it's a strike slip component to it, or something else that's got a sort of in echelon graben formation. I'm not a structural geologist, but that's what in the seismics, that's what's been published, and that is what I see from the drill core as well. There's a serious east-west orientation in the basement in some areas, and there's in the distribution of the formations, there's also a component of that. So we need to do much more work. We got the seismic data is also available. We've got all the drill core, and we need to understand this better to understand the Garwal craton better.
Okay, the name you were looking for, was it Ian Plimer or Plimer? The long deceased guy from Australia?
No,
it was more like Electrate, wasn't it? Trendle.
Yeah, there's Trendle. Yes, Alec Trendle. Okay. That's it. Yeah, long, tall guy. He had a hip problem. I don't know what happened, but it was him. Yes.
Okay. Kulakani Kumalo wants to know: do you think that the domal uplift is related?
Well, I certainly think that if you look at the picture of back arc basin widths and whatever, and all the loading, then it rebounds and it starts doming, and then also with all the magma coming in, certainly there must have been a substantial doming
to a mantle plume. Yeah, sorry, I missed out the last part of the text there.
Yeah.
And just a general question, and going back to your comment, Gerhard, about there needs to be more work. I mean, I'd be interested to hear from Lou. You've got a great team of people there working on the Ventersdorp. I mean, is there sort of an initiative to have a broader relook at the Ventersdorp? Obviously, I think your focus is on the geochemistry, but you and your students, and what's the attention of all that work?
Yeah, we don't have any plans to do any dating, which is going to be quite a mission to locate proper samples and then extract zircon and then analyze it. That's not our focus, but that kind of thing certainly needs to be done, because I agree with Gerhard that I'm uncomfortable with that 80 million, whatever it is, million year gap between these two lips. I not comfortable with that. Our focus is on the isotope geochemistry. So we're going to do strontium, neodymium, and hafnium isotopes in whole rocks throughout the entire Ventersdorp. And I think in 2 weeks you're going to hear a talk by Kulakani, in which he will describe his results on that so far. Maybe focusing in that talk, I'm not certain, on the fantastic stuff that we've been getting from the Western Area Formation.
Good. Thank you. Gene Simmons wants to know, any comments on the geohydrology changes and variations in the Ventersdorp group regionally, Gerhard?
John, I've got no idea except the stuff near the surface, like Allen Reach, is very substantial. I mean, it's quite tight, and there's very little water unless you get. I don't know. I haven't got much. The Ventersdorp in general is very tight, so I don't think it's got much potential except at the big faults. So yeah. Henny, I saw there was a question from Ronnie Glass about all that drilling of Anglovale and, you know, did they find anything? Well, certainly, Target Mine started up as an extension from the Agglomerates mine going northwards towards Whitterville. And it's been extended, and they're busy drilling 2 boreholes there at the moment. One is almost finished or finished as far as I know, I don't know. Just to confirm or firm up some more of the resources to see if they can extend the mine further. There's very good grades all the way towards Whitterville, huge resources, but it gets very, very deep. And to draw that to the extent you need for a compliant or a measured resource from surface is massively expensive. That's how they also done Target, I believe, and is still doing a lot of the drilling is happening underground. It's much cheaper, but at this time, the hydrothermal gradient in the Free State Goldfield is of course much higher than any of the others. So at about 2,000 meters, I think they're about as hot as 3.5 on the West Rand. So it is not feasible really at present technology to mine those deposits down there towards Whitterville. It gets towards 4,000 meters, you know, and more, yeah.
Okay, there's another comment from Nigel. Can you read that on the side there?
Yeah. Yeah, no, it sounds very interesting, and I'm glad there's work done on Ventersdorp, Klippriviersberg. Like I said, I never really worked academically on Klippriviersberg, or not really focusing on that. It's part of the bigger picture, but I would like to see work done on these boreholes outside the Witwatersrand Basin, because that changed the complete picture. The Bloodberg Group within the Central Rand, which is mostly Whitterville area, is so unrepresentative of the Bloodberg. And that's what we still base our stratigraphy on. Not that it changed drastically at all, but if you go west, things change drastically. Just a comment on my haloclastites west of the Central Rand Basin. Hard for me to imagine how you can have 600 meters of Klippriviersberg haloclastites deposited very soon after Central Rand Basin, which is supposedly all this uplift from the west and this island that was sitting there, that of course we can't find. And then you have this huge basin where there was water. Or what is the story there? You know, was it a thick glacier? I don't know. It's really a puzzle, but if we work on that, we will find the answer.
But I think there again, Gerhard, just to comment, I mean, a lot of the sort of new work or the clearer insight into the Ventersdorp has been, you know, has come from your and Willem's work out in those sub-basins or you know, more widespread areas with it. I mean, that massive pile sitting in the middle of the Wits is, as you say, very hard to sort of properly unravel.
Yeah, John, one really need to get a nice, and I tried to, but one need to get a nice research group together that's got legs and that can work on this stuff. It's sitting in the core yards. It's available. My agreements or interactions I had with companies in the past, they said by all means do whatever you like, because it's no economic interest, financial interest to them. Yeah. And we need to do something, because you start seeing all sorts of other things that's part of the bigger picture. And where will we get boreholes like that again? I'm not talking about 1 or 2. I'm talking about hundreds of boreholes outside the basin, and deep boreholes. I mean, where I'm sitting here in Clarence, there's a borehole just over the hill here, a few kilometers outside. There's those holes that's drilled for this Bethlehem Basin or whatever they call it. And I mean, there's borers here with 3,500 meter core going all the way to basement.
Well, I thought by now you would have unraveled the south end of the Wits as well. I mean, aren't you almost sitting on top of it there, you know, where you are, or just a bit further east of you?
Yes, John, but unfortunately there's no gold here as far as I know, so nobody wants to give me money to have a look at it.
Yeah. And last question for me. I mean, I find the chemistry or the geochemistry interesting. I mean, you talk about andesites. Are those, is that generally or genuine andesites, or is that, you know, the low grade metamorphism and upping the silica in the process?
Yeah, John, that's a interesting one. I was wondering when that will come up. I always called them basalts, and the Allen Ridges are basalts and so on. But if you really think about it, I can't see how you change the whole chemistry, especially all the silica you need to change the whole pile to a high basalt, low andesite. And the classification I use and you can use more mobile elements as well. It just scatters more, but you comes up with the same answer. But if you use zircon, yttrium, and so on, it doesn't classify as basalts. So I don't think they are real basalts. I think they are, and if they're real basalts, they will be different tectonic setting. So them being high basalts, low andesites, and andesites when you go to Bloodberg makes more sense from the tectonic model one has of the whole Wits and Ventersdorp setting.
And just my little bit of knowledge, I mean, the chemistries are actually quite consistent too, you know, across the basins and elsewhere. And I'm talking about things like silica and how we would generally
John,
rank.
if you, yeah. I've spent actually years cleaning up data. I've accumulated all the data I could possibly get and added some more recently. And it's not that there's a problem necessary with analysis, but I constantly cleaning data. If you look and go into detail of the thesis, a lot of the sampling were poorly done. It was just every 10 meters or 20 meters, not discriminating between the lava flow tops or, you know, those areas where there's more fluid movement and much more alteration. And that you can see in the course. You must strictly adhere to it as dense, unaltered material, the middle of the flow. So first of all, you must recognize the flows. And it carries, and that's true for Goed Genoeg and McQuasy as well. I haven't encountered anybody that could show me the ash flows in McQuasy yet, because they don't recognize it, because you must get your eye in and then you start seeing the amygdales and so on. And if you rely on that kind of samples and samples that analysis of samples that's not good samples, and then so many correlation problems. I recently added a thesis that was done years ago, considered to be excellent work. But I know some of those borers and some of those areas, and I was surprised to find it's rife with correlation errors. You got the wrong formation there, you're in the wrong part of the sequence. So if you use that data, you will come up with wrong conclusions. You have to clean that properly. And once you do that, the data actually starts gelling very well, and you do see regional consistency in the data very clearly.
Interesting. Okay. All right. We're starting to run into coffee break time. Any other questions? Comments?
Well, thank you very much, everybody. I think, Gerhard, you've set the bar very high, making this topic so understandable to a lot of us guys and rising the interest. We're looking forward to the next 2 episodes, next week and the week after, where we take this story further.
Okay. Thanks, Gerhard. That was excellent.
Thank you, John. Thank you for the opportunity, and thank you, Eni, and everyone else that listened in. and might listen in future, I appreciate the opportunity to give a bit of an overview of the Ventersdorp.
Okay, and you're available to take on students at the University of Clarence there and get your whole research group going again, and let's unravel the Ventersdorp for the second or third or fourth time.
Absolutely, John.
Ed, are you there?
Yeah, thanks very much, Gerhard. Yeah.
Thank you, Ed.
Okay, guys, that wraps it up for today. See you all next Thursday, same time, same place, and
Yep.
same topic.
Good.
Thank you, Ed.
Thank